Okay, we are back with some quick math. We are dealing with some grade 10 content today. This is angles in a Cartesian plane. We are busy with some trigonometry. Like the videos, subscribe to the channel and share it with anyone doing math grade 10. I'm sure they will benefit from this. Okay, so as I said, we are in a Cartesian plane. Before we even get to the question, there are certain things that we need to know before we can deal with this. Okay, so when we are not in a Cartesian plane, let's just put up a right angle triangle over here. If we are not in a Cartesian plane, then we know our ratios in a right angle triangle, right? It has to be a right angle triangle. If we maybe have A, B, and C here, and you have a theta over there, we know our ratios because of SOHCAHTOA, right? SOHCAHTOA. Make sure you know that word. Understanding what it is and knowing the word helps you with your trig ratios. It becomes super easy. Okay, so sine of theta. Okay, let's write sine of theta will equal to opposite over hypotenuse. O is for opposite, H is for hypotenuse. In the triangle that we have over there, if theta is over here, opposite would be over there. So that's going to be A over hypotenuse is always the side that is opposite the 90. Okay, so the hypotenuse is C. Okay, cos of our theta, that would end up being adjacent. What does adjacent mean? Adjacent means around the same point, right? So this is the point over here. The two sides that are around this point are B and C. So B and C are both adjacent to theta, right? But we know that C is already our hypotenuse, so B is our adjacent side, right? So cos of theta is adjacent, which is going to be our B, divided by H, our hypotenuse, which is our C, and similarly tan of theta in this case is going to equal to opposite, which is our A again, over adjacent, which is our B. Okay, so that's all true. That works very nicely when I am not in a Cartesian plane, right? Okay, let's maybe just mention this as well. If our point of reference changes, so what I'm saying is, if I'm over here, let's maybe make this alpha. If I'm dealing with alpha and I want sine, so sine of alpha, now my opposite is going to be over there. Okay, so opposite is not necessarily always the same place. It is always in reference to the angle that you have. Okay, so if you have alpha, which is over here, then opposite is going to be my B, and hypotenuse, that one's always going to be the side opposite your 90, so that's our C. Similarly, cos of alpha, okay, alpha is over here, so cos adjacent is the one around the same point, or we can think next to, so that's going to be A over C, and then also tan of alpha is going to be tan of alpha is going to equal to, tan is opposite over adjacent from SOHCAHTOA. Opposite is going to be your B over adjacent, which is your A. Right. So when you're not in a Cartesian plane, all of this is nice. That works fine. What about when you do enter a Cartesian plane? Okay, so there's going to be certain things that you need to know when you work in a Cartesian plane, because SOHCAHTOA, as much as it's valid and it helps, it's not going to help you in your Cartesian plane. Right. And in order to determine your ratios once you're in your Cartesian plane, I'm going to draw our first quadrant, right? So this is our Cartesian plane, and I'm going to draw a line in our first quadrant over here, and this point has a coordinate x, and it has a coordinate y, because we're in a Cartesian plane, and this line has a certain length, right? The length we're going to call r, so that length is r. Okay, and now we're going to draw in a triangle that is created over there. So there's a triangle that is created over here. That triangle is a right angle triangle, so here's a 90. Okay, this length over here, that length corresponds to my height, which is my y. Right, so this is going to be y, and this length over here obviously is laying nicely on our x-axis, corresponds to our x. Okay, our theta is going to be over here. right? So I'm drawing this in our first quadrant, and I'm going to use this drawing in my first quadrant to create generalizations for ourselves. Okay, so I'm going to create new ratios. Instead of opposite, hypotenuse, and adjacent, all of those things, I'm going to have it in terms of x, y, and r. Okay, so still SOHCAHTOA, right? SOHCAHTOA is still going to help me. Let's write SOHCAHTOA here again. SOHCAHTOA, know it off by heart. It helps you with all of your trig at this level, at least while you're in a right angle triangle. It helps you. Okay, so SOHCAHTOA. So sine, okay, in my Cartesian plane, sine of, we still have theta, right? Theta is over here. Sine of theta is going to equal to opposite. So in my Cartesian plane, my opposite is my y. My adjacent, or okay, well, we need hypotenuse. Your hypotenuse is your r. So it's y over r. Cos. Cos of theta is adjacent in your Cartesian plane. Your adjacent is your x. Hypotenuse is still r. And similarly, tan of theta equals tan is opposite. Opposite is your y over adjacent, which is your x. Okay, so these are the ratios. Okay, once you are in your Cartesian plane, these are the ratios that you would need in order to solve a question like this. Right? So I'm going to stop this video over here. The next video will actually delve into the question, but for this video, in order to deal with angles in a Cartesian plane, those are the ratios that you need, and this is where it comes from. Great.